Hi, it's Mr. Andersen, and this is AP Physics Essentials, video 75. It's on systems. And this is the first of 25 videos that are going to deal with the conservation laws, which are best described by Richard Feynman as things in science that stay the same. So his analogy is, imagine you have a kid who's playing with blocks. The number of blocks, we'll say, is equal to n. And so let's say it's 20 blocks. And so this kid, no matter how they put those blocks together, the number of blocks, 20, is going to be conserved. It's going to stay the same. And if we were to go in there one day and find 19 blocks, that would mean that one of them has been lost. And if we find 30 blocks, they must have been brought in from somewhere else. And so figuring out in physics, what are the blocks? And then more importantly, what is the system? What is the room where these blocks are contained is important if we ever hope to solve the problems. And so a system is going to be two or more objects that are separated from their environment. But if that whole system has no internal structure, then we just count that as an object. And so if we have a system, a series of two or more objects separated from their environment, whatever's inside that system is going to be conserved. It's going to behave according to these conservation laws. Now those blocks or those objects or that energy could be energy that's conserved, it could be charge, it could be momentum, it could be linear, it could be angular momentum. They're going to stay the same within that system. And if it's not, then we've got ourselves an open system. And so a system is a collection of objects. And so in this case, we've got a pulley system. So we've got the pulley, we've got the rope, we've got the weights on either side of it. And so we count that as a system made up of objects. But if we were to take one of those objects and look inside it, we know that it's made of iron, which is atoms, and those atoms have subatomic particles, and then we have fundamental particles inside of that. And so why do we treat this as an object? It's because it has no internal structure, or at least no internal structure that's important in solving this problem. So we simply treat it as an object within this greater pulley system. And so did you learn that a system is a collection of objects that have no internal structure? I hope so, and I hope that was helpful.